What's going on, everyone? I think this is my first live in a long time on YouTube, and I am now using OBS. We got the background music in the back. Super excited. So we're going to go ahead and start covering the solutions that I have posted on my Instagram. I'm just going to kind of go ahead and show you what that looks like. These were the problems that I have. So we have a good amount. Let's see. I think I left off on the partial derivative, and then we have this integral here, and then we have this one, and then we have that one, which I posted yesterday. And then I have, oh my goodness, a good amount of problems. And then we have this one. Okay, so we're just going to review all of them. Feel free to let me know if I made any mistakes. And please, if you like what I do, follow me on Instagram, follow me on TikTok, subscribe to my YouTube channel. Let's do this. Okay, so let's go ahead and close this. I believe I left off on this problem. I'm just going to go ahead and write it on the screen real quick, and then we'll get started. Man, I have been on this crazy live kick lately. I've been going live on TikTok the past 3 weeks, every Tuesday, Thursday, and Friday, and it's so exciting. Oh my goodness, don't listen. There is an ad in the background. Did not expect that. Okay, we're back, guys. So now that we have the problems right on the screen, let's go ahead and start solving it. So this one was asking to find the partial derivative in terms of x. I guess I just asked for partial derivative in terms of x. So if we're going to do that, don't forget that we're going to take the derivative like we normally do, and we're going to go ahead and treat y like a constant. So this one's actually pretty simple. We're going to take the derivative of the first part, and that's just going to be cosine of x squared y plus x y squared. And then we're going to multiply by the derivative of what's inside. So remember, we're treating y as a constant, so really that inside becomes 2xy plus y squared. All I did was take the derivative of x, which was 1, and then the y squared stays there. And now I have 1 over xy. I'm going to write it as to the power of 1/2 because I know that I'm going to have to take my derivative. And now we're going to take the derivative of that inside value. So this is going to be 1/2 xy to the negative 1/2 times the derivative of what's inside. But don't forget, this is a partial derivative. So this is just going to be y. Let's see if I can kind of rewrite this. This just becomes 2xy cosine of x squared y plus xy squared plus y squared cosine of x squared y plus xy squared. And then minus, oh geez. So this is going to be y over, I think the bottom's just going to be xy, which is kind of nice. Oh, and then there's a 2 as well. And I forgot that this is going to be equal to 0. Why 0? Because if we look on the right side of the equation that I had in the very beginning, the derivative of 6 was just going to be 0. So we're good. Okay, I guess the only thing that we can really do is cancel out the y that's on top and the bottom on that last term. So we're just left with this. That is our partial derivative in terms of x. Not bad, right? Okay, so that was that first problem that I had not completed. I have other solutions on there. You could also go to the YouTube playlist. Kind of looks like this. Watch. Go to my channel real quick. Oh, what happened? Like missing. Hold on, give me 1 second, guys. So if you go to the playlist, I'm always going to have solutions on here. So you go to the Instagram solutions, and it should have all the solutions that we want. Well, we don't want to watch any of that stuff. But anyway, just so you know, you can always go to that, and that is on the link in my profile, whether you're on Instagram or on TikTok. You'll see that. Okay, that was that problem with partial fractions. or partial derivatives, I'm sorry. And now we're going to go to an integral problem. So I'm just going to go ahead and write that on the screen. And then I'll go back to the blackboard. I think in the comments, if I recall, I was reading these, and a lot of people were looking at the cosine squared. They were looking at this and did not notice that there was a cosine squared of 2x and started thinking that this was going to be a cosine of 2x, just a double angle for cosine. That's not the case. But we're going to talk about this, okay? So the first thing that we should do is maybe rewrite sine squared using the power reducing formulas. And this is going to be 1 minus cosine of 2x over 2. And then this one out here is minus. Now we got to rewrite that cosine squared. What's that cosine squared? I guess I could also do a power reducing. And it's going to be 1 plus cosine of 4x over 2 dx. Okay, so again, I was using the power reducing formulas. Hopefully you can remember them, but this is one of them. So sine squared x is equal to 1 plus cosine of 2x over 2. And then cosine, whoops, it's a minus, I'm sorry. And then cosine squared x is equal to 1 plus cosine of 2x over 2. So proud of myself. I see that I was not writing where my face is, so that's kind of nice. Okay. Now this is going to become 1/2 minus cosine of 2x over 2 minus 1/2 and then minus cosine of 4x over 2. All I did was just split these up because they have the same denominator. The 1/2s cancel out, which is kind of interesting. And now we have integral of negative cosine of 2x over 2 minus cosine of 4x over 2. Okay, now we can solve this using U substitution. Let's make some space on the blackboard. You guys have been watching any of my TikTok lives. We always talk about how we make space on the blackboard. And also I guess my videos, my shorts and everything. Okay, here we go. So we're using U substitution. U is equal to 2x. du is equal to 2 dx. And let's divide the 2 to the other side. I like dividing the 2 just because I'm able to isolate my dx. So my du over 2 is equal to d. Okay, and technically we also are going to use U substitution for that second integral, but I'm just going to use w so I don't confuse the two. Let's do w equals 4x. dw equals 4 dx. Let's go divide the 4 to the other side. And I get dw over 4 is equal to dx. Awesome. All right, guys. So now what do we have? Let's go ahead and rewrite our integrals here. So I have negative cosine of u over 2 times du over 2. Don't worry, we'll fix everything up in a bit. Minus integral of cosine of w over 2 times dw over 4. All right, for that first one, we can go ahead and multiply the 2's and pull them on the outside. So now we're going to have 1/4 integral of negative cosine of u du, and then minus 1/8 integral of cosine of w. All right, hopefully that makes sense. And now this is going to become negative 1/4 sine of u minus 1/8 sine of w plus c. And now we just put everything back. Don't forget our u was 2x. Minus 1/8. And then our w was 4x. And now we're done, people. That's it. Not bad, right? Again, let me know if you catch a mistake here. I feel like I'm always thinking of, I'm making sure the stream's working. I'm making sure, you know, all systems are good on my end. So like, I feel like I have so many things to focus on when I'm doing this, but hopefully that makes sense. So let's go ahead and erase this. You know, one thing that I'm going to do, just give me 1 second, guys. Okay, we're back. Okay, let's go ahead and find that other problem. Let's go to the next one. Oh, I'm on the wrong one. La 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 la. There should not be any ads playing. I hate that I'm playing this lo-fi music, but it's on YouTube. Mess that up. Anyway. Okay. So that was that integral. Now we go to the next one. Okay, seems like something messed up there. Okay, so now we have, geez, having technical difficulties. This does not want to work for whatever reason. Oh, I know why. My Zoom over here. Okay, so we had finished this integral. Now we're going to go to this next one. Hope I didn't skip it. This one, yes. Okay, so let's go ahead and write that on my screen, and then we're going to work it out. I think this one's going to take probably the longest out of all the problems. I have 1, 2, 3, 4 more problems to do. And I think this one's going to take the longest. Almost guarantee it. All right. So let's get to it. Let's go ahead and move the 6 on the outside. 2x squared minus 9x plus 7. Eesh. And it looks like maybe some people might want to do u sub, but that's probably not going to be the best option. So what we're going to do is, let's do some partial fractions. I think this is going to definitely simplify or factor out. So let's see. The way I like factoring is doing the slip and slide. So 2 times 7 is 14. And then I have -9. So two numbers that multiply to positive 14 and add to -9. That is -7 and -2. But then because I multiplied by 2, I have to divide by 2. And now I have -7 over 2 and then -1 over 1. Nice. So look how this is going to factor out. I have dx on top. And then the bottom, I have 2x minus 7 and then x minus 1. Nice. All right. So as I mentioned, it looks like it's going to be a partial fractions type problem. So we are going to have to write this as a over 2x minus 7 plus b over x minus 1. And hopefully we are familiar with partial fractions, because this will become a times x minus 1 plus b times 2x minus 7 is equal to 1, I believe. Yep, this is going to be 1, because on the numerator, it's only 1 that we have. We don't have anything else. I know the 6 is on the outside, but we don't account for that. Okay, so I think this is called the hidden method, or that's the way some people like to describe it. They plug in a value, and they look at the parentheses here, and they said, hey, for that first one, if I plugged in a 1, I'm just going to get 1 minus 1, which is 0. So that's going to go away. So it's kind of neat. Now we have x is equal to 1, so then we plug it in. A times, and then we have 1 minus 1 plus b times 2 times 1. I like the color here. It's kind of nice. All right, so as I mentioned, that 1 minus 1, the a's cancel out. So now we're left with negative 5b is equal to 1. So b is equal to negative 1/5. Pretty cool, I would say. All right, so now we know that b is equal to negative 1/5. We can plug in almost anything. Let's do 0. That's probably going to be the easiest one to look at. So x is equal to 0. And now we have a times 0 minus 1. Oops. Plus, or I guess now we can do minus 1/5, since that's what we know the b value is going to be. Times 2 times 0. We know that's going to be 0. And then minus 7. Can y'all see that? Yeah, I think that everything... I want to make sure that I'm not like writing somewhere that you can't see on the screen. But okay, this is going to simplify to 0 minus 1 for the first one is negative 1a. And then minus 1/5 times 2 times 0 is 0 minus 7. So negative 7 is equal to 1. Ooh, okay, so let's go ahead and create some space on the blackboard here. We already know that's the case every single time. Okay. Let's go ahead and this up front. Okay. So continuing on with this problem, we have negative 1a and then plus 7/5 is equal to 1. Let's subtract the 7/5 to the other side. And this is where you should know some of your fractions. So negative a is equal to negative 2/5. So then a is equal to 2/5. Okay, so now we have this integral. Let's go ahead and move it. If we look back at the integral that we had when we started doing the partial fractions, this integral is going to be 6 and an integral of the a value, which is 2/5 over 2x minus 7 dx, and then minus 1/5 over x minus 1 dx. Okay, it doesn't look like it blocks my screen, which is great. Okay, so as we continue this, or the way we're going to solve for this is we're going to make our u equal to 2x minus 7. So then du is equal to 2 dx. du over 2 is equal to dx. And on the other one, I'm actually just going to still show the work. W is equal to x minus 1. dw is equal to dx. Okay, so now we have this amazing integral. 6 integral of 2/5 over u times du over 2. Minus, I'm just going to actually put an integral on here too. 1/5 over u times over w, I'm sorry, times dw. Okay, a couple housekeeping things. This 2/5 and the 2 can go on the outside. So let's kind of show how that's going to work. This is technically 6 divided by 2 times 2/5 integral of du over u minus, and then on that second integral, let's go ahead and bring the 1/5 on the outside. And then we get 1/5. Whoops. Didn't want to do it in green. I want to keep it yellow. 1/5 integral of dw over w. Okay, that 6/2 over 2, those two fractions, those 2's cancel out, so we're left with 6/5. And then now we can take the integral of that. That's natural log absolute value of u. Realize that's an ugly, ugly u, so let's change that. Absolute value, I keep doing w, u, there we go. Minus 1/5 absolute value of w, and then plus c. All right, not going to leave y'all hanging. I'm going to go ahead and change this up. Let's make this smaller, because I'm definitely going to plug in our u's and our w's. Guys, there's ads playing on here. Okay, I'm going to switch it to a different a different problem, that's for sure. Let's skip that. Okay, let's go ahead and do a different lo-fi. Jeez, I really trusted this one. I thought this was going to be the case. Yeah, it looks like we're good now. All right, so let's go ahead and this is the things when you go live. Mistakes happen, and it's just, that's just what it is. You gotta roll with it. Okay, so now we have 6/5 natural log of our u value was 2x minus 7 minus 1/5 natural log of our u was, or our w in this case was x minus 1 plus c. Here we go. That's that problem. Okay, let's go ahead and erase this. And let's go back and look at our Instagram here. Whoops, wrong one. It was one. Okay. So we had this problem. And again, I always like to do like one problem or two problems in a reel and then two more problems in a reel. And people seem to really like that. So it's kind of fun. Interesting enough, I did a problem very similar to this on yesterday's live on TikTok. It was an integration bee. That was kind of fun. But let's go ahead and do this one. Did I just make a video on this? I might have made a reel on this and it's going to come out soon. But let's go ahead and work it out together. Okay. All right. So let's go ahead and minimize this. Perfect. Here we are. Okay. So typically this looks like a u substitution problem. And it is. The only thing that we're going to make our u equal to is that entire square root. That helps me eliminate the square root. And so now we can go ahead and square both sides to get rid of that square root. And we have u squared is equal to ex plus 2. And now we can go ahead and find our du. So 2u du is equal to e to the x dx. Let's go ahead and divide the e to the x to the other side. And we're left with 2u du over e to the x is equal to. Okay. So let's go ahead and substitute that into our integral there. So we have integral of, remember, the u was the entire square root. So now we have u times, and then this du is 2u du over e to the x. All right, let's go ahead and rewrite that a little bit. This is now going to become 2 integral u squared over e to the x du. And so we got to fix that e to the x. How do we do that? Well, we definitely know what it is because we know that u squared is equal to the e to the x plus 2. So if you move the 2 to the other side, we can say u squared minus 2 is e to the x. And now we can go ahead and plug that into our integral there. So now we have 2 integral of u squared over u squared minus, oops, I said minus 2. Beautiful. So in this case, we have an integral where the degree of the top is the same as the bottom. So we're going to go ahead and simplify this using long division. We're not going to do partial fraction decomposition. So we're going to go ahead and use long division. Our u squared is on the inside, and our u squared minus 2 is on the outside. And so that's just 1. How many, what do I need to multiply the u squared? La, 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 la. Yo, I am sick and tired of these ads. I'm so sorry, guys. I don't want it to play because then I play it on YouTube and it gets copyrighted. So kind of frustrating. Anyway, back to the long division. I wanted to find a value that when we multiply to u squared, we get u squared itself. So that's going to be 1. So then I multiply the 1 to both of these and I get u squared minus 2. And then I can go ahead and subtract this. This is so funny because it's something we learned in high school, or as a junior in high school, I would say. And then it's almost like we have to revisit 6th grade material. Or like 4th grade almost, you can say. Okay, so this is now going to be the u squareds cancel out, and then we have a 2. So our integral is going to be this. 2 integral of 1 plus 2 over u squared minus 2. E. Oh, goodness. Looks like we have to use partial fractions in that second one. Wasn't expecting that. Whoops. Sorry, guys. move this stuff on accident there. I need to move or create some space on the blackboard there. Okay, the windows there. My buttons are all over the place. Yeah, I will get better at this. This is the first time going live on a different system here, so it's kind of nice. But just something to keep in mind that this will continue to get better. So we have 2 integral of 1 plus 2 over u squared minus 2 du. That first one is pretty simple. It just becomes, I'm just going to do 2u plus, and then this is going to become 2 integral of 2 over u. Yeah, I don't want to do partial fractions there. Or I'm sorry, I don't want to do partial fraction decomposition. I really don't. Because it's u squared minus 2. Don't want to do that. I just don't, guys. Because then it's like root 2. I mean, let's try, shall we? Okay, so according to partial fraction decomposition, this is u minus root 2 plus b over u plus root 2. So then a u plus root 2 plus b u minus root 2 is going to equal to 2. Well, let's use that hidden method again. So if x is equal to root 2, then that b cancels out. So we're left with 2 root 2a is equal to 2. That means that a is equal to 2 over 2 root 2. And I'm just going to multiply by the conjugate there. Again, if you guys catch a mistake here, because this just feels odd that this will be the answer, let me know, please. Okay, so this is 2 root 2 over 4, which is just root 2 over 2. Okay, so now we know the a value is root 2 over 2. And let's try a different one. X is equal to negative root 2. Then that means that negative 2 root 2b is equal to 2. And I think we can confidently say that this is negative root. Okay, so it looks like I need to create some more space. Go. All right, so now we have 2u plus 2 over, and then here we go with the root 2. So this was root 2 over u minus root 2 minus root 2 over u plus root 2. And now we can easily integrate this using some u substitutions. Partial fractions get really easy once we do this. So this is going to become 2, and then we have root 2 over 2 natural log of u minus root 2 minus root 2 over 2 natural log of u plus root 2. And the whole thing's going to be plus c. Geez, I thought I wrote it a little too big there. Gotta guess I have to create a little bit more space. So a few things that I'm going to do. I'm going to multiply the 2 to both of these values, and you're going to see that the denominator of 2 is going to go away. And then I'm going to go ahead and plug in the value of u that we had originally. And u was equal to the root x plus 2. So now it looks like this. 2 root e to the x plus 2. And then plus root 2 natural log of root e to the x plus 2 minus root 2 minus root 2 natural log of root e to the x plus 2 plus root 2. And the whole thing is plus c. Woo! I think I lied. The last problem, which I thought was going to be easier, or was going to be longer, ended up being a little easier. This one was a little more difficult. Yeah, how many more problems do we have? Let's see. Okay, so that was one of them. Let me go ahead and clear this. Okay, so that was one problem. And now let's go ahead. Yes, I think this was posted, what? Yesterday. It was a day ago. And everyone seems to have all the answers. I think a lot of them, everyone has 9 halves. And I think that's all. That is correct. But I'm just going to go ahead and draw it real quick, and I'll show you guys how we do this. I think I covered this on my live yesterday as well. All these problems are just really fun to look over. Yeah, so it looks like we need to find this area here. So this function was 3x minus 1, And then the bottom function was x squared minus 1. Okay, so in order to find the area between or area under between the two curves, excuse me, there you go, we're gonna have to find where these functions are equal to each other. So we're gonna do 3x minus 1 is equal to x squared minus 1. So we're gonna go ahead and let's bring everything to the right side. We have a quadratic, so that's exactly what we're gonna have to do is set it equal to 0. So I'm gonna add the 1, which cancels out with the minus 1 on the left. So we have 3x is equal to x squared. And then let's go ahead and subtract the 3x to the other side. And now we get 0 is equal to x squared minus 3x. Beautiful. Looks like we just factor. X times x minus 3. So our solutions are x is equal to 0 and 3. What are these values? These values are where the function intersects. So looking at the diagram, it is here at x is equal to 0, or I guess we can say here. And then up here, this value of x is equal to 3. So then we need to find the integral from 0 to 3 of the boundaries between the two functions. And the way we're going to do that is we're going to take the top function, which is the linear one, it's a straight line, minus the quadratic. Okay? And let's simplify some stuff before I even implement the first fundamental theorem of calculus. This will become 3x minus 1 minus x squared plus 1 dx, so that the 1's cancel out. And so now we have integral from 0 to 3 of 3x minus x squared. All right, let's do it. This becomes 3x squared over 2 minus x cubed over 3 using the power rule. Lost my train of thought there. All right, and according to the first fundamental theorem of calculus, we're going to plug in 3, and that's going to give us 3 times 3 squared over 2 minus 3 cubed over 3. And then we're going to subtract the value that we get when we plug in 0. And that's just 0, so we're not really going to worry too much about it. So now what we have, it looks like we have 27 over 2 minus, this looks like it's 9. And so I guess I could just get common denominators, 27 over 2 minus 18 over 2. And this is what everyone got, 9/2. Easy enough. Yeah, these are always fun. It seems like a lot of people on Instagram really enjoy the area problems. Well, highly suggest that we continue you continue working on those. I think I have another one that I'm going to post soon, so be on the lookout for that. Okay, so let's go ahead and erase this. And I think, how many more problems do we have? Let's see. We have this one, another real, as I mentioned. Oh, and this was the newest one that I got. Awesome. Okay, so we're going to do this last one, and then we'll be done for the day. But before we finish, or before we get started, don't forget to please subscribe to this channel. Follow me on Instagram. Follow me on TikTok. I mean, I'm trying to post different content for every social media. So you're missing out if you're not following me on all of them. If you're a math nerd like me, please go ahead and do that. Okay, so here we go. This is the problem now. So what we need to do is we need to find k. So that means that there's a value, an area underneath the curve from the parameters k to 2k plus 1 of this function 2x plus 1, and that's equal to 40. Well, let's not be scared of that. Let's just go ahead and take the integral of the 2x plus 1. So this becomes x squared plus x. And then we have our parameters from k to k plus 1. And we can already set this equal to 140. We're going to go ahead and plug in the 2k plus 1. So that's going to be 2k plus 1 squared plus 2k plus 1. And then we're going to subtract the values that we get when we plug in the k. Now look at this. Be very careful. I'm actually going to put a parenthesis here. So this could be k squared plus k, because I don't want to forget that I need to distribute this negative sign to both terms. Okay, so let's just go ahead and distribute those negative signs. We'll be on our way soon. So this is negative k squared minus k. And don't forget, this was equal to 140. Well, now it just looks like a simple quadratic problem. So then what we could do is we can go ahead and FOIL that first one. And that's going to become 4k squared plus 4k plus 2 plus 1. And then we have plus, and now we go ahead and rewrite the rest of the problem. 2k plus 1 minus k squared minus k is equal to 140. And now I got rid of the parentheses because there was nothing to distribute in front of it. There was no negative sign, so we're good. All right, let's go ahead and combine like terms. So I have the 4k squared minus k squared, that's 3k squared. I have the 4k and the 2k and then the minus k. Ooh. So that's 6, that's plus 5k. And then we have the constants that we need to add. 1, 1, and I think that's it. So that leaves us with plus 2 is equal to 140. Okay. Let's just go ahead and create some space and we'll be done. Okay, well, it looks like we still have a quadratic. So then what I'm going to do is subtract the 140 to the other side. So that we get 3k squared plus 5k minus 138. La, 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 la. Guys, oh my goodness. More ads playing on this. I need to literally just buy some royalty-free lo-fi music to play with no interruptions. Or maybe I should get like YouTube premium or something. Anyway. Okay. So back to this problem as we got interrupted. We have 3k squared plus 5k minus 138 is equal to 0. We are going to go ahead and factor this. And I think it factors out. I'm hoping it does. So again, I'm going to use that slip and slide method. I'm going to multiply the 3 times negative 138. 3 times negative 138. You're going to see why I'm not even simplifying that. And then the bottom is 5. So I need two numbers that multiply to that product. 3 times negative 138 and 5. Let's see. I know 138 is 2 times 69. So this is 3 times 2 times 69. 69. 69. So 3 times 2 times 23 times 3. So let's see. Could it be 23 and... Oh, 23 and 18. So it's going to be 23 and then negative 18. And then because I divided... Oops, that's a 23. There you go. And because I divided or I multiplied by 3 initially, I have to divide by 3. And then simplify those fractions. So this is negative 6 over 1. Whoops. Negative 6 over 1. And then the other one is just 23 over 3. So then we get that this solution right now looks like this. 3k plus 23 times k minus 6 is equal to 0. And now we're going to get our two solutions. K is equal to 6 or negative 23 over 3. Okay. Now, some people like to get picky. Both of these are correct. Some people would say that it's only 6 because 6 has to be the lowest one or the smallest value. And so that means that the upper sum should be the larger one. So some people are going to argue that the answer is just 6. I personally think that it's both. But you guys can definitely leave something in the comments to argue that. Before we leave, let me go ahead. I'm just going to erase this real quick. And I want to go ahead and see what people are saying on this Instagram problem. Oh, shoot. Oh, it's missing the DX. Oh, I cannot believe I forgot that. Hold on. Let me like that real quick because they are absolutely right. They are absolutely right. Give it. All right. But let's pretend it's there. The answer is, so this one over here, so k is equal to, so this one Pavel said it's 6 or negative 23 over 3. And here we go. By the fundamental theorem, k is equal to 6. Let's see. What about k equals 23 over 3. So let's see. I love these discussions. Some people get really adamant that it's, you know, it has to be one way, but math is just about having fun with it. And then shout out to Math Mindscapes for having the answers. Shout out. Okay, cool. So let me just go ahead and post all solutions posted on my YouTube Live. All right, guys. So this is where we end. I'm just going to go ahead and tell everyone in every comment here that all solutions are now on the YouTube Live. On YouTube playlist. I guess I should say playlist. But anyway, I'm going to try to do YouTube Live maybe once a week. Try to post all those solutions to the problems that we have. But I'm always on TikTok on Tuesdays and Thursdays and Fridays. Tuesdays is Integration B. Thursdays is some sort of definitely learning targets. So I think this tomorrow I'm probably going to do related rates. And then Friday is off trail. So we're probably going to do some like Feynman techniques. We'll see, maybe some McLaurin series. And then I'll try to go live on YouTube. I'll try to have a schedule. But if you guys feel like there's a specific time you want me to go on, please feel free to let me know in the comments. But yeah, in the meantime, if you like what I do, subscribe to my YouTube channel, follow me on Instagram and TikTok, and we'll continue to post more math content for y'all. All right, guys, take it easy. Bye now. Ta.